Welcome. In this video I will show you what the reason is why we are using functions. Functions can make our life a lot easier, mainly because we use functions that yeah, are tested by others or by ourselves, and after they are tested we can use them as much as we want to. Well, and how does this work? I have an example in this case, and the example is as follows. We have some kind of, let's call it a production line, and what we have is that products will come in here, and then, for instance, can go to the right here or go further up to another belt or whatever. Well, products are being placed on the belts from below here and are traveling upwards. And at several positions along the belt we have ultrasonic sensors in our case. And this one is number 1, number 2, 3 and 4. And these electronic sensors will send out an ultrasonic signal in this direction here. And when it bounces on the product, the ultrasonic sound, it will bounce back to the sensor, and the sensor is able to determine the distance between the sensor and the product on the belt. Depending on how the products are being placed on the belt, of course, in the middle or here to the left or to the left or the right, the distance may vary, and also the position of the sensor, the distance between the sensor and the belt may vary. You can see it here. This S1 is very close to the belt, S2 is a little bit further away, and S3 and S4 are almost at the same distance from the belt. Which means that when a product travels on this belt, this one will return a lower distance value than S2, for instance. So that's how it works. And we are now going to create some kind of program for it. The program that I started to design is given here. And what you can see is that I created some sensors, variables, sensor time 1, 2, 3 and 4, which should store the traveling time of the ultrasonic sound from each sensor. And I also created product present variables that will somehow store whether a product has been detected by a sensor or not. Okay. So what I need some kind of function that we supply in our library, which you are going to use at a later stage during the course. But just assume that we have some kind of function, ultrasonic read pulse time, and I pass a value here, which is the sensor number. So 1 for this, 2 for that, 3 for that, and 4 for that. And the first thing you can see is that it is not being recognized by our program, in this case implicit declaration of this function, which means that it cannot find how to use this function. Well, it's in a header file, as we learned, and in our case the description of how to use this function is in ultrasonic.h, and when I add it to our code you can see that the editor is not complaining anymore. And when I build it, you can see that things are not being used, but for the rest compiling itself is okay. Only the linking stage where a program is being generated, it complains about ultrasonic pulse time function not being present, and that is okay because we should add a library, which we don't in this case. Okay, so basically our program is able to read a time from a given sensor number. Now, what we should do then is we should somehow determine whether a product has been seen by the sensor. And that means that somehow, say, product sensor 1 has, sorry, I should say another way. This sensor generates a signal, and the value of the measured time depends, like I said, about on the distance between the sensor and the belt, but also the position on the belt of the product, which means that we have a range of sensor values that will tell us when the product is present. So in code I would get something like this: if sensor time 1 is, for instance, bigger than 25 and sensor time 1 is less than 50, I should not forget our extra braces. If that's happening, then product sensor becomes true, and otherwise it becomes false. So we determined that depending on the position of the product here, the value of this sensor should be between 25 and 50, then there is a product present here on the belt. Well, we could do the same, of course. For instance, for the second product, just simply copy and say, okay, our sensor time 2 value should use the second sensor, but it's a little bit further away, so this should be between, for instance, 40 and say 65, and in that case we determine that our product will be true, and if the sensor value read here is outside these limits, then it should be false. Well, of course I can copy this again for the other two sensors, and then we should have a working program. However, it would be even better or nice when we could somehow reuse this code somehow. And if you look at it, the code is almost equal, only the variables and the values here are different. Well, how can we solve this? Well, we will create a function that we are going to reuse as much as possible. The function should return a Boolean value, like we have here for product present, true or false. And how will we call it? Let's call it is product present. And we are going to give it several values. First of all, some kind of number, which will be the sensor number, so 1, 2, 3, 4 from the items here. And we should also pass the minimum and the maximum value of the range for the sensors. So something like an min time and max time. And then we can simply copy the code that we already prepared to our function. Of course, we are missing variables in this case because we define them over here. So let's just take it from there, and also we would need a bool for the product present. And in our case, there is no relation anymore between the number of the sensor and the variables we are going to use. We just say, okay, we have a sensor time that we read, and then if the sensor time is between two values, then a product is present or not. And of course we have to return a value because we say that a bool should be returned. We will return the value of product present. And the last few things we should do, we still have the old values of the sensor number to be read and the limits. And now the sensor number is given by number here. So we pass the number to our function and the minimum time is there. And the maximum time is here. So now we have a function. We call it isProductPresent. We pass the sensor number 1, 2, 3, 4 and the minimum and maximum time that we measured for a product to be present. And then the function will first read the specific sensor and then determines based on the minimum and maximum time if the product is present or not. And when it has computed that, it will return the value of product present, which is true or false. Then we have to, of course, use it in our while loop here, which means that we will say product present 1 equals calling the function for which number, the sensor number, and the minimum value we have here is 25 and the maximum value here is 50. And then we can remove what we created here. And of course, for the second sensor, we can do the same. We need value 2 over there, and in this case we would need the values of 40 and 65. And let's just assume that we will also do this for 3 and 4. 3 and 4. Number 3 and 4 is the number. And these are a little bit further away than S2. So let's make it 50 and 75. And they both had the same values we said. So, well, that's it. This is our program. The code in the while loop here has been minimized. It's now only 4 lines, and these 4 lines do the same as the number of lines we would have early in the stage by copying everything. And now it's a little bit more flexible. So what does it do? Product present 1. These can be removed. We don't need them anymore. Product present 1 will get the value that is determined by isProductPresent, and isProductPresent is the function that will be called here. And the first time it will get sensor number 1, or number 1, which should read the sensor. Number 1 is given to number here. In that case, 25 is assigned to min time and 50 is assigned to max time, and then the function will determine the product present value, and when it returns, the value is assigned to product present. And the same for the other function calls. So this line will do it for sensor 2 with the minimum and maximum values, and the same for sensor 3 and sensor 4. Well, this is why we are using functions. Our code becomes smaller and more clear because this function should describe what it does. And the other advantage is that we make one function that we use several times so that we don't have to copy paste everything. And if we find some error in this code, we just correct it in this function, and then it's corrected, of course, for all these lines at once. That's it for now. Until next time.